This is 12-2 continued. So what's happening here is we're going to need to try to find the length of a chord. In this case, they're asking us to find BD. So some things we know that this radius AE is 5, and AD is a radius that I'm drawing in here. That's also 5, and I'm going to use Pythagorean theorem to find side CD. So this is actually a 3, 4, 5 triangle. It's a Pythagorean triple. Since CD is 4, I double that to get the full length of BD, and so therefore BD is 8. Step 1, we're going to draw a radius that goes from the center to one of the endpoints. I chose PR in this case. Step 2, you're going to use the Pythagorean theorem, and I pulled out the triangle so you could see it a little bit better, triangle PTR, to find the length of TR. I'm calling that B in this case, so I did A squared plus B squared equals C squared, and solve for B. So I solved for B, and I got 17.32. You can keep the radical if you want as well, which was 10 radical 3. So it doesn't matter which one you keep, either 10 radical 3 or 17.32. And step 3 would be to double that number so that you can get the full length of the chord. So I'll highlight this piece, that part of the chord right there, the bottom half of the chord, is 17.32. So to get the full QR, we would double the 17.32. Double the side to get the chord. So our final answer is 34.64. This is 12-3, sector area and arc length. There's 3 things that you're going to need to know from this lesson. One of them is area of a sector. A sector is like a slice of pizza, so this is ACB, sector ACB right here. It's the area of the whole circle, but then we're multiplying it by a fraction because we want part of that whole circle. A fraction is a part of a whole, so we want the part of the circle that we're talking about. And so once you multiply that, you get your final answer. That is your area. The M up here could either be the central angle or the arc, because remember, central angle and arc measure are congruent. So we start with our formula, A equals pi r squared times m over 360. We plug in our values. Since r was 3, I plug that in here. 3 squared is 9, times our fraction, which is our degrees. In this case, I use the arc, 80, which would be the same as the central angle, and divide it by 360. So in my calculator, I can put 80 over 360 as a fraction, or I can just simplify that to 8 over 36. Multiply that by 9, and I get 2. Put back my pi, and it's always going to be inches squared because it's area. 2 pi inches squared is the final answer. So to find area of a segment is basically from the chord to the edge of the circle. And so area of a sector would get us our full pizza slice minus the area of the triangle. It sort of just leaves the crust is how I think of it. So the area of a segment is like the crust. So area of the sector using pi r squared times m over 360 minus the area of that orange triangle right there, 1/2 base times height, will leave you the little piece left that we're trying to find, the area of the segment. Okay, so area of a sector, I plugged my information into area of a sector. I got 24 pi, which I then calculated to be 75.4. Now I'm working on the area of the triangle. This is not the easy part because I don't have my base or my height. There's one thing you could recognize, that this is an equilateral triangle, so it's going to be 12, 12, 12. Or you can draw a line down this triangle. I redrew my triangle over here. There's my radius of 12 and my other radius of 12. And so I drew a line straight down so I could work on getting the height. I know that this angle must be half of the 60, so that's 30. And so from there you can either use 30, 60, 90, or you can use trigonometry to find the bottom piece and the height. I may have just made an error there, so I just want to point this out in case. This should be 12. The base of this triangle is 12. The base of the triangle, the small triangle that I was looking at was 6, so we double it to get 12. So it's half of 12 times 6 radical 3. Finding arc length is different than the arc measure that we were talking about before. Before we said an arc measure is the same as the central angle, so it's measured in degrees. But now we're talking about arc length, the length of this red piece right here, this arc length. Well, the whole circle, the length around or the distance around is circumference. So we're using circumference formula, and we're taking a part of that circumference. So you just plug your numbers into this formula, and you'll find the length. And remember, it's regular units, not units squared, because it's just like you're measuring that little piece. It's not the area of it. So regular units for your final answer.